Okay, so if you have any questions or comments, feel free to post them here or enter them in here. questions@ritsec.club. We like your feedback. We appreciate your feedback, and we take it seriously. So please do give us feedback. So yeah, moving on. We have. Do you want to go over? We have a few announcements to go over, like 2 announcements. So the first is we have a new junior tech lead. So Troy, you want to come up and introduce yourself?
Hey guys, I'm Troy. It's my second semester here in RIT, and yeah, I became the junior tech lead. So if you guys have any problems in terms of demos, you can always message Troy, CHOI. So yeah, thank you.
Thanks, Troy. Yeah, thanks to Troy, and thanks to everyone who really applied to junior tech lead. We do appreciate all the applications, and it was a really tough decision, but yeah. So, anyways, another announcement: the CyberOps Intel Interest Group. So, if you want to learn more about, I believe this is following. Is Jason here to actually speak to this? I don't want to steal his thunder. No? All right, he's not here. So I will steal his thunder and try my best to make this as interesting as possible. So, yeah. So if you want to do research on threat actors and different malware groups. So on and so forth. This is a great interest group that's starting up. I believe Jason is spearheading this along with Kyle Schleich. And yeah, they are going to be going through breach walkthroughs, malware reviews, industry speakers, and so if you are interested, you can contact Jason. His email's right there. And when we post these slides, his email will be in there. So feel free to reach out. But this is a great interest group to get involved if you're interested in learning more about malware, and maybe not so much the reversing side, but more of like the movement and following the botnets around the entire globe. So very cool. So now we're going to get started on to our education portion, which is week 5, the intro to cloud. So and we have a guest presenter this week. We have Susan who just graduated last year. So she's a cloud expert, so she's going to teach you all about it. So give her a warm welcome.
Yeah, sure. Sorry.
Talking at the mic.
Susan, I missed you.
1 second.
All right. Hey, what up? Okay. Hey, all. My name is Susan. I was the ops lead last year, and now Brandon is ops lead, and he's doing a better job than me. Good job, Brandon. I have a background in doing DevOps / systems engineering, specifically working with AWS and other cloud technologies, but now I just write application logic, and it's really boring. So I would go into this or security instead. Don't be an application developer. Are we presenting? Yeah. All right. So, you know, cloud's kind of a meme, or it has been. I know a lot of you are starting to realize it's very actually important in the industry, and there are several cloud services that exist. Many companies use them. And the whole reason for using the cloud is that it makes it easier for infrastructure engineers. It gives them another set of tools. They don't have to worry about hosting their own hardware and all the problems that come with that. So like having to hire network engineers, having to hire and buy people that can pick out hardware, it gets really expensive. And so it's actually usually cheaper to run things in the cloud than it is to host your own infrastructure. And you don't have to deal with the litany of problems that come with that. So it's basically, these cloud services give you a variety of networking tools, virtual machines, containers depending on what service you're using, and many other things that make this easier. And today I'm going to mostly focus on AWS because that's the big one that most companies use. DigitalOcean is another big one, Azure and GCP, but they all have their own individual tool set that is flavored for their applications. So to break down what I'm going to be talking about, we have AWS computing, AWS storage, and a bunch of other services. The computing kind of falls under EC2, which is your typical VMs. There's something called ECS, or EC2 containers, which is containers. And Lambda is another thing that allows you to what they call statelessly run your applications. So if you don't want to have to worry about the underlying operating system, installing the needed packages you need, you can run it through Lambda. So there's a variety of reasons that that's really good. I'll go into detail for that. For storage, we have S3, which is block storage. Think of like NFS or other distributed block storage systems. It allows you to store all your files, all of your images, a variety of other things that will make your life easier and you need storage for. There's also the Elastic file system for creating a network file system. And other things, which is also what makes AWS really cool. You have RDS, which is like a database as a service. You have some data warehousing stuff for Hadoop and big data. And there's a variety of other tools that make it nice. So let's go into more detail on the compute nodes. The biggest thing that most people are familiar with AWS is EC2. So this is kind of like the bread and butter of AWS. You have your VMs and you can run anything you want on them. They have a variety of operating systems you can pick from, all the way from Windows to BSD to all the Linux flavors. A lot of really nice tools. And the nice thing about this is that you can really run anything you want. So if you don't want to pay for RDS, which is the relational data store, you can just stand up a MySQL instance on your own. When I was working at Slack, we did not use any of the plug-in AWS data store stuff. We just ran MySQL master-master pairs in EC2, and it worked out really well. You also have Lambda. Lambda's kind of like this new hotness that exists that allows people like, hey, I don't want to pay for this entire VM. I don't need all the sources, like all of the tooling here, so why don't I just give Lambda my application to run. Let's say I'm like swooping files back and forth between web servers and it's its own application. I can run that in Lambda and it does it as a one-time service. You get charged per cycle rather than for RAM and storage, and it's a really nice thing. And so you can also plug it into other AWS services like S3, EC2, and DynamoDB, which I'll talk about later. It's like a Mongo thing. And then another service they offer for compute nodes is ECS, which is also the new hotness. It's Kubernetes as a service. I don't know if anyone's familiar with Kubernetes. It is a container orchestration tool, and it allows you to communicate conversations between different container services. It's really nice, and it's kind of a pain to set up on its own. So AWS offered ECS, which takes care and abstracts all of that away from you, so you don't have to manually worry about setting up Kubernetes. And it's really nice for if you have like a minimal microservice or a small web application, so you don't have to put it up on the big expensive EC2 instances. All right, storage. So a little bit more detail about S3. There's a concept of S3 buckets, which is just this block storage that you can put anything you want to. You can have it in different data centers, etc., and it allows you to access it from anywhere. So one big thing people do is they will have all of their logging just forward to an S3 bucket. So then you can scrape that S3 bucket and process logs how you want, instead of having to like scoop them over to EC2 where you're also paying, you know, for RAM or cycles or whatever. It allows you to just put it in that bucket. And there's also EFS, which is not super used, but it is NFS for AWS. Yeah, a lot of acronyms. It's really cool. One thing that I am very familiar with is the RDS and DynamoDB. So they are AWS's databases as a service. You have RDS, which is MySQL and Postgres, and now they have something called Aurora, which is like allows really easy distributed talking between those two. So you can spin up 3 RDS instances in different availability zones, and they'll all talk to each other seamlessly. It's called Aurora. It's really nice. DynamoDB is their NoSQL database. It's either based off of MongoDB or CouchDB, I forget, but it's really, really useful for a variety of applications. So I used DynamoDB when I was working at a company called Honeycomb to deal with distributed clients on each machine. And what they would do is those clients would talk to an S3 bucket, pull down a log, and process it. But we didn't want to like pull down the same log from the same S3 bucket, so we used DynamoDB to put a key in the DynamoDB table saying, hey, we've already read this S3 bucket, you don't need to pull it down again. And since DynamoDB takes care of like concurrent actions, it was good on putting a lock on that S3 bucket, so we weren't able to read from it again after we'd already pulled down that log. There's also a couple other services, Elastic Cache, Redshift, EMR, which is their Hadoop cluster. They basically offer a lot of very big open source technologies as services, and you can pay for them. All right, so for you networking nerds, AWS also offers a lot of tools around networking. One of them is VPCs, which are like big subnets that you can use to group your different machines together, EC2 instances. Security groups, which are like IP tables, but for IP tables for instances. They act as a whitelist. CloudFront, which is a CDN, and Route 53, which is AWS's DNS. So more details on the virtual private cloud. So VPC is a network, and you're given like a 16 block, is it called, of IPs, where you can have all of your machines assigned to static IPs within this network or dynamically allocated IPs in this network. You can additionally divide that VPC into further subnets, so you can have a public subnet or a private subnet within that VPC, and you can, from the internet talk to that public subnet, and then, the machines in that public subnet can then only talk to the private subnet. So if you want to sanction off things that way, it makes it really easy. AWS has 3 availability zones per region. So there's a region is something like Virginia, another region is Washington, etc. And they have 3 AZs, so 3 data centers in each region. So you can have your hardware or EC2 instance or whatever in each of these 3 AZs. So if one router goes down in one of the AZs, then you can just have it route to those other traffic zones. Public subnet shown to be. The nice thing about a public subnet is it gets, I think it's called an elastic IP, attached to that subnet, and it allows for all machines in that public subnet to be under one IP. So you can distribute traffic that way and load balance traffic that way, instead of having to assign an IP to each one in this public subnet. One big, very common thing to do is attach something called an ELB, which is an elastic load balancer, to the top of that subnet. So if anyone's worked with HA proxy, it's very similar, and it will route all incoming traffic to whatever rules you set. So one very common thing is you have a bunch of web servers sitting in this public subnet, and you have an ELB which evenly routes traffic to each of them. And then we have elastic load balancing, which I just described. Cool. Oh, yes, security groups, okay. So security groups are a list of IPs or ranges that you allow to hit your box as well. So you have to specify both IP and port. So if you're like, hey, I want to allow all traffic in on all ports, you would be 000, and then a star to indicate all ports are open. That's a very dangerous thing to do. You don't want to let all traffic in, but it does act as a whitelist. So if you create a new EC2 instance and assign it to a security group that only allows traffic from one specific IP, you're not going to be able to hit it from any other IP and any other port. The nice thing about EC2 security groups is that you can have multiple security groups on one instance. So let's say I want to allow all IPs in from this set of IPs and another set of IPs, but it allows you to break things out a little bit more nuanced. I guess there's a new thing called VPC security groups. which is basically if you have multiple VPCs, they used to not be able to talk to each other, but now VPC security groups allow, if you were to add them to your VPC, allow these different VPCs to talk to each other. And then these other services are pretty critical. You need Route 53 DNS. If you ever want to have a public DNS record of your box, you have to add it to Route 53. And they allow you to assign it from domain to IP, just like every other DNS service. You also have the CloudFront Global Content Delivery Network, and it allows people accessing application globally through fastest routes. Okay, this was edited. All right, sorry. Somebody else looked at this and changed some of the wording. But it allows you to very specifically put routes of what machines are going to typical CDN. And the really nice thing about the DNS and CDN is that you can hook it into other services within AWS. So you can hook it into EC2, you can hook it into your ELBs, you can hook it into S3. So if you want, every time you go to a certain website, you want them to go to this index page that's sitting in S3 bucket, you can use CDN to route them that way. So here we get to like the more security-oriented stuff. AWS has this idea of an IAM role, identity access management. Think of like how you have different users on a Linux box. You have your administrator, your wheel group, etc. And an IAM user is one that has a certain set of permissions, and you hand out a key and ID to be able to have them access it. So developers, for instance, might not have access to your prod EC2 instances, but they do have access to the staging and development EC2 instances, because you don't want some developer to get owned and now everyone has access to your prod environment. One big mistake that people use when they first start using AWS is making an IAM user that is a root user. So they have access to create services at whim, delete services at whim, look at all your look at all of the information that is being routed between everything. And it's really common for people to be like, okay, we have this one IAM user that's now root. Let's give it to everybody at the company or everyone in your group, because it's just easier, because developers want to create machines. They don't want to have to go through the ops people every time to create a machine. And it can be really, really dangerous. So make an IAM user that's not root, and don't share the root account user. And it allows you to have fine-grained control over permissions. Apparently, there's a new service called AWS Key Manager Storage, or Key Manager Store. And it allows you to encrypt your keys that you hand out to people. So let's say you have an IAM role on a specific instance, because you don't have to only give it to people, you can give it to instances as well. So applications can, if they need to ever reach out to the AWS API, they can do their own thing. And it allows you to encrypt those keys, so you don't have any of those keys sitting in source control of your application. If anyone's heard of Vault, it's very similar to that. AWS offers a whole suite of tools that are really, really good for security engineers. And they don't actually automate away security engineers. They just make your lives a lot easier. So you have CloudTrail, which allows you to monitor all activity on your account. So if anyone's making AWS API calls, et cetera, things like that, traffic on your box, what's happening. You also have Trusted Advisor, which will kind of scan your AWS account and see what security groups are in use, if there's any vulnerabilities that you should be aware of. Are we using IAM? Is MFA enabled? It's a hardening tool. You also have a certificate manager. You have to pay per cert. You have configuration integrity, which looks at all of your configuration for different instances and says, hey, this might be a problem. And it alerts you if any of those configurations change. So if a box gets owned or something, or like somebody has an AWS key that they shouldn't, and they change a configuration on a box to let them in, it'll alert you to it. There's a couple new tools called GuardDuty and Inspector. GuardDuty does automated threat detection. and it uses a bunch of machine learning tools to see, hey, what traffic is common that you're sending between these instances? Oh, wow, this web server is sending gigabytes and gigabytes of data. That's probably a bad thing. It might be owned, and alerts you. And it also detects unauthorized access to your account. So if, oh, hey, there's this foreign IP that all of a sudden logged in with your credentials, that could be a problem. And Inspector does something very similar, but it monitors traffic specifically between instances. Do I have any questions yet? Okay, where do I see that? Probably not, okay. Well, that's at the end. Hello? Okay, there we go. There's also something called AWS WAF. So it's a web application firewall. It's a little bit different from a security group because it is VPC wide rather than just on an instance. So it sits between your VPC and all traffic going out. You can add all sorts of things to monitor what's going on, but it requires a lot of configuration. And there's AWS Shield, which is their DDoS protection, kind of like Cloudflare enables that. And they also have a secrets manager, which I talked about earlier for encrypting your various secrets that you have in your application for specifically IAM roles and a couple other AWS specific things. So it's kind of a pain to go into the AWS console. If anyone's been there, it's really ugly, it's hard to use, doesn't make sense. But luckily, there's a lot of tools that exist that allow you to programmatically stand all of these instances up, so you don't have to click through the API every time, or sorry, through the web UI every time. And it also makes it so you can stand these instances up really fast. So for instance, at Slack, when we had a shard, what we called a MySQL shard, which was the master pair go down, we could just press a button and stand up another 2 instances without having to, that were already configured, already had all of our credentials on it that we didn't have to click through. And what we used was Terraform. And Terraform is one of these infrastructure as tool, or yeah, infrastructure as code tools that allows you to programmatically stand these up. Terraform's really nice because you can do it with GCP, which is Google's cloud, Azure, AWS. It offers plugins for all of these variety of AWS, all these variety of cloud tools. And the big thing that most companies use is AWS CloudFormation. It's specs written in JSON or YAML that allow you to stand up these variety of services. And I guess you can plug it into Ansible and Puppet to create these CloudFormation templates. There's Packer, which is another HashiCorp tool for creating VM images, and directory service. So if you want Active Directory, you can have it. So this is kind of like a typical setup for what like a SaaS company would have. A SaaS company being, service as a service, so something like Slack, where they host Slack and you can use it, Facebook, et cetera, et cetera. So the user will hit the ALB, which is the public-facing IP that has a DNS record attached to it, and then the ELB will evenly route traffic across these different web servers. The web servers are all going to reach out and talk to this RDS, which is sitting inside of a private subnet, so nothing can talk to it, and as well as the S3 bucket, maybe to retrieve images or whatever, your static hosting files from another private subnet. So these two can't talk to each other, and it's really nicely separated, and traffic is routed with minimal effort. Common EC2 secure. So Amazon has started to get better about this, but it used to be that the default, when you would create a default instance, a lot of these security holes were there. So for instance, you would create an EC2 instance, and it would have a security group that automatically allowed all traffic in. So you would have to edit that and make sure. Now it gives you an alert to say, hey, you're allowing all traffic in. Are you sure you want to do that? Another common mistake, as I talked about, people accessing things from the root AWS account, which you don't want to do. You really only want to use the root AWS account to make other accounts and IAM roles that have certain permissions. You don't really ever want to use it to create and manage and administrate your instances. And it's really easy. Just enable CloudTrail. It will dump everything that it finds into an S3 bucket. You can look at that S3 bucket and set up alerts. A lot of people don't enable this, and you won't be able to see like what API access is going on in these accounts or if somebody breaks into something. So one really nice feature of EC2 is that you can take snapshots. I think VMware has this capability as well with their VMs. You can take snapshots. And if you have your passwords hard-coded in any of the configuration management, let's say you're using Puppet or Ansible, and you have Ansible insert that password from its vault, and now that's on the machine. So those snapshots now have that password embedded if you were to download the snapshot and look at them. So you now have access to these people's boxes. And snapshots should really be restricted per account. So it can be dangerous that way. So this one's kind of weird. There is an IP that exists that I've listed here that allows AWS instances, regardless of account, regardless of IAM role, to send metadata back and forth. And one of those is like sending IAM keys back and forth to find out who, so you can grab people's IAM keys and assume them as a user. If you can make requests to EC2 instances, you can find the IAM key. So one of them is to block this IP with security group, or not allow it with your security groups, so that they can't talk to your EC2 instance. But if you can make a request at this IP to an EC2 instance, it's really likely that you're going to be able to find the IAM keys that are translating between them. That's another reason why you should really nuance and lock down your IAM keys so that, hey, somebody gets access to this one web server, and look, they have the IAM key for it, but that IAM role can't do anything, so it doesn't matter. They can't see anything. So a lot of people use S3. There's a lot of common mistakes. Luckily, Amazon has kind of made it so it's harder to put these broad restrictions, because when you first were able to create an S3 bucket, it would give broad permissions on all of the S3 buckets. And you could have unauthenticated users can look at the contents. So if you're using the AWS API and you're not authenticated with that account, you could ping that S3 bucket and get all the information about it, which could be dangerous. And then another option you can set is only authenticated users can look at certain at the buckets. So if you register with AWS via their CLI, you can still look at the S3 bucket, and you have default read and write permissions on the bucket. A more common mistake people make is putting their Git directory in S3. So let's say you're just hosting a front-end web app like Angular or some other front-end framework, and you have your Git directory sitting in that framework, in that S3 bucket. People can pull down the Git directory, search it to see if there were any passwords or any credentials in the Git log history or Git commit history, and get some of your credentials that way. And I guess people mount S3 as a file system. I think Ben knows more about that, but he's not in the room. All right, so I think this slide is really important. Why should you care about cloud? There's a lot of different terms here. It sounds really complicated. And as I said earlier, AWS and cloud hosting is exploding everywhere. Everyone's using it. It's really popular. If you have AWS on your resume, you are going to get flagged by so many recruiters, trust me. Engineers who are competent with working with these cloud providers, or at least know the terminology and can learn a new cloud provider, get paid big bucks. And if you're a security engineer who knows how to use the security tools within AWS, you can make even more big bucks. So it's really important to learn these things. And it's also introduces a lot of interesting problems. How do you deal with IAM roles being exposed via an IP endpoint? How do you deal with developers who might not have the right credentials or have too many credentials? There is a project here called Space Crab that deals with a lot of the well, it deals with exposed IAM keys, and it's a honeypot for that. And yeah, this last point, I don't know much about clearance, but knowledge of AWS and a clearance translates into working for the government and making a lot of money doing AWS GovCloud stuff. All right. So the last few slides are more on how to create an AWS account. And you can download the CLI, which is mostly what you will be using to interact with AWS. It makes your life a lot easier to use the CLI instead of clicking through the GUI, and it exposes you to a lot more information about like what availability zones things are working on, et cetera, et cetera. And here's instructions. I think these slides are available afterwards, right?
It will be.
Okay, cool. And here's more instructions on how to register your account with the CLI, because with many EC2 instances, S3 buckets, et cetera, that you create, they will be locked down, so only a registered account can look at them. So you will have to register via the AWS API, and that's all done in dot files. Here's some useful commands. Also, I listed a ton of resources that are really important to know when you're working with AWS, plus some like cool security thing. There's flaws. The flaws CTF will teach you probably more than this presentation did. And it's an excellent breakdown of vulnerabilities within the AWS infrastructure. And it's pretty frequently updated to find the new stuff. Demo time?
Demo time. Hey guys, if you go to demo help, that's where the new demo is. And it's Cloud Week this week, so we're not giving out a VM. If you click on the form, you'll have information on how to access each challenge.